So today we are going to talk about the semiconductor diodes, right? So move to the slide number 2. So first we are going to talk about the semiconductor diodes. Okay. So Goodbye, let me know that if we talk about the semiconductors. So what do you know about the semiconductor?
Yes, alright, semiconductors, they're like insulators that can conduct electricity.
Yeah. So basically these are those materials in the periodic table, just like these are those elements in the periodic table which are having their conductivity that is less than that of the typical metals. You may have studied about the metals, that if we talk about the metals just like the sodium, the potassium, the iron, so these are the typical metals which are having greater amount of conductivity. And if we talk about the non-metals in the periodic table, so can you give me an example of the non-metal in the periodic table?
Yes, sir, chlorine.
Yeah, so if we talk about just like the chlorine, the sulfur, oxygen, so these are the elements which are non-conduct, which are not the conductors of the electricity. So if we talk about the semiconductors, so their conductivity is in between the conductors and the insulators. So that's why they are called as the semiconductors. So the first one point about the semiconductors is the semiconductor diodes is these are made up of the semiconducting or the semi metals. So made up of semiconducting materials. And if we talk about the semiconductor diodes, so these are having a special, you can say that the nature or the special place in the physics. So the next one point is if we talk about the representation, so their representation is very important, because whenever you would talk about the circuits, so you would come across the circuit diagrams, and these circuit diagrams would contain the circuit symbol for the semiconductor diode. So most of the time the semiconductor diode is just like made in this one way, that there is a circle outside present, then there is a triangle shape, then there is a band, and then two lines are drawn in this one manner, right? So this is basically the circuit symbol for the semiconductor diode. Got it? So you can say that this is the circuit symbol. And it's very important to understand the circuit symbol for the semiconductor diode, because when you would put the semiconductor diodes in the circuit, so you can put them in the two different ways, right? So we can say that if we talk about that what parts are present in the semiconductor diode, so the part that just like you can say that the tail of triangle, the back side of triangle, this one portion, this one is considered as the anode in the case of the semiconductor diode. So this is anode, which is the tail of the triangle. And if you talk about this one, front portion, so this side is considered to be the cathode. Got it?
Yes, sir.
Okay, so goodbye. Let me know that if we talk about the anode and the cathode in the physics, so what do you understand from anode and the cathode? What does it mean?
Anode and cathode, they're electrons.
Yeah, these are the electrodes. But can you tell me about their charge?
The or anode is negative and cathode is positive.
No. Goodbye. Keep in mind that when you are talking in the physics, so in most of the time when you are talking about the circuits, so anode is always taken as the positive electrode. Got it? So if you're talking or dealing with a cell, so the positive terminal of the cell would be considered as the anode, and the negative terminal of the cell or battery or any component of the circuit, it would be taken as the cathode. So it means that if you are going to talk about a semiconductor diode, so the front portion is considered as the cathode, and the backward portion of the semiconductor diode is considered as the anode. Got it? So if we talk about the placement of the semiconductor diode in the circuit, so it can be placed in the two different ways. And based upon those two different ways, we can say that either our semiconductor diode is considered as the forward biased, or it is considered as the reverse biased. Right? So move to the next one slide. The first, we would talk about the forward biasing of the semiconductor diode. So if you would put the semiconductor diode in the circuit just like this one manner, I would first draw the circuit diagram of the forward biased semiconductor diode. Then we would discuss that how it is placed in the circuit. Got it? So first we have a battery here. This one is our battery. So this is the positive terminal of the battery and this is the negative terminal. So if we have placed a semiconductor diode in our circuit, so this is our semiconductor diode, and then this is the placement. So such arrangement of the semiconductor diode is considered to be the forward biased. Now I would let you know that how you can understand and how you can recognize that whether your diode is forward biased or the reversed bias. So I have told you that the front side of the diode is considered as the negative and the back side is considered as the positive. So now you can see that the positive side of your diode is connected with the positive side of the battery, and the negative side of the diode is connected with the negative side of the battery. So in this one case, your diode is considered to be the forward biased. Did you get it?
Yes, sir.
Okay, so now I would write about it. So we can say that when anode, or you can say that the positive side of diode is connected with positive terminal of battery, and negative side, or we can say that first we will talk about the cathode, and cathode or negative, cathode or negative terminal, negative side is connected with negative terminal of the battery. So then your diode is considered to be the forward biased. Got it? Goodbye, did you get it?
Yes, sir, I got it.
Okay, very good. So this is the circuit that I have drawn at the slide. So when you would see this type of the circuit in your circuit diagram, so you should surely come to know that your diode is forward biased, right? So now jump to the next one slide. Now we can talk about that whenever your diode is forward biased. So we can say that its resistance is very small, right? So we can talk about here that its resistance is very small in this case, and a large amount of conventional current would be what is conventional current? What is conventional current? Your mic is muted. I can't hear you.
Oh, sorry, sir.
Yeah.
Sir, could you repeat the question?
So I was asking you that what is conventional current?
Okay, I was saying, conventional current is like Uh, it's like a charge per unit time transported in a certain direction.
Yeah, basically keep in mind that I have told you that conventional current is considered to be flowing due to the flow of positive charge. So it is the current which is thought to be flowing because of the movement of the positive charges, right? So if we talk about the circuit in which the semiconductor is considered to be placed in the forward biased, so it is said that just like jump to the previous one slide. So we can say that if we look at this one slide, so as it is mostly considered in the physics that current starts from the positive side or the positive terminal of the battery, and it flows through the semiconductor diode, and then it goes to the negative terminal, right? So this current is considered to be flowing due to the movement of the positive charges from the positive terminal of the battery to the negative terminal. So that's why it is said that a large amount of the conventional current is thought to be flowing in the circuit when your semiconductor diode is forward biased. Got it? So this is about the concept of the conventional current. So keep in mind that the current which flows due to the movement of the positive charges, that is considered as the conventional current, right? So move to the next one slide. Whenever your semiconductor diode is placed in the forward biased manner, so its resistance is very small and a lot of conventional current would flow through it. So goodbye, did you remember that we have plotted the IV curves for different types of the conductors or different types of the materials? So if we talk about the IV curve of the semiconductor diode, so we can plot it again here. So if this is the manner in which we are going to plot the IV curve for the semiconductor diode. So it is said that if you are going to have the forward biased manner of the semiconductor diode, so then how the diode would behave or how the IV curve would be produced for the diode. So let me draw the curve on the slide, then I would let you know that what does this curve means. So it is said that if we talk about the IV curve, so the here on the x-axis we have taken the voltage, and on the y-axis we have taken the current, and the graph look like just like this one manner. So this type of graph is given for the semiconductor diode, and what this graph is showing you, it is said that if we talk about the upper portion of the graph, I would mark it on the slide. So if we talk about this portion of the graph, just like from this one to this one portion, so this is considered for the forward biased manner. So resistance in this portion of the graph is considered to be very small, and you can see that you are having a large amount of current flowing through the circuit. Got it? So goodbye, this portion of graph for the semiconductor diode is produced when your semiconductor diode is forward biased, right? So the next one manner in
Yes,
which,
sir.
okay, so the next one manner in which you can place the semiconductor diode in the circuit is the reverse biased, but before talking about the reverse biased manner of the semiconductor diode, we again move to the previous one slide. So move to the previous one slide. So suppose goodbye we have put a lamp in the circuit just like here. So here we're going to put a lamp. So did you remember that this is the circuit symbol for the lamp, right? So we have placed a lamp in the circuit. So if your semiconductor diode is forward biased, so when you would flow the current through the circuit, so this lamp would be lit it, right? Because large amount of current is flowing through the circuit, and when the large amount of current would flow through the lamp, so the lamp would become lit up, right? Okay.
Yes, sir.
Okay, so now move to the next one slide. We can write the last point about this one, that lamp is lit in this biasing, right? So when you would put the semiconductor diode in the forward biased manner, so then the lamp would be lit up. Got it? So goodbye. Now jump to the next one slide. We can talk about the next one placement of the semiconductor diode, and that is basically called as the reverse biased. So in the same way we have done for the forward biased, first I would draw the circuit diagram for the reverse biased, and then we would talk about that what is basically the meaning of the reverse biased. So suppose we have a battery just like here. So you have semiconductor diode placed here, attachment. Okay, so now you can see on the slide this one is the, sorry, we should change the polarities. This should be considered as the, yeah, now it's fine. Positive terminal, negative terminal. Okay, so goodbye. Let me know that uh, which one side of the semiconductor diode is positive and which one is the negative one.
The reverse, yes, sir. The reverse diode, so like it will be the
Okay, listen.
like
I would place this side is the A and this is the side B. So now you can tell me that which side is positive, which side is negative.
A is negative, B is positive.
No, no, goodbye. I have told you that you have to tell me not on the basis of the terminal of the battery. You have to tell me about the anode and the cathode of diode.
Okay. So A will be positive then. And B
Yeah.
will be negative.
So this is the positive terminal of your diode and this is the negative terminal of your diode. And now you can see that in this one manner, the positive side of the diode is connected with the negative terminal and the negative side is connected with the positive terminal. Got it? So this placement or this attachment of the diode in the circuit is considered as the reverse biased. Got it?
Yes, sir. Okay.
Hmm. So here the polarities are the polarity of the battery and the polarity of the diode is just opposite to each other. So that's why it is called as the reverse. So now we can write down about the reverse. So when anode of the diode is connected with negative terminal of battery and cathode of terminal and cathode of diode is connected with positive terminal so this placement of the diode is called as the reverse biased. Did you get it?
Yes.
Okay. So now jump to the next one slide. So just like I have told you about the forward biased, that the resistance of the semiconductor diode is very small, so a large amount of the conventional current flows through it. But if we talk about the reverse bias, so we can observe that resistance is very large. So resistance of diode is in reverse biased. So very small current flows through it. So goodbye, I have told you that if we talk about the resistance, so you know that where the resistance is large in the circuit, the current is very small. And goodbye, this is the same current we have discussed in the previous one discussion about the forward biased. So I have told you that we are going to talk about the conventional current, right? So jump to the previous one slide. So if we talk about the flow of the conventional current, so can you tell me that from where the conventional current would flow in the circuit?
in the reverse bias?
No, no, no. You have to tell me about the polarities of the battery. So the conventional current flows from the positive terminal of the battery, right? This one, just like we can say that it would start from here, go here. This one, it should then go from post this one side to this one, because this is the usual way for the flow of the conventional current. But if we talk about the diode, so diode would not allow the current to flow from the negative side to the positive side, because this is not the usual way of the flow of current in the diode. In diode, the current can flow from positive to negative terminal, but the flow of current from the negative to positive terminal of the diode is not allowed. So that's why its resistance becomes very very large in this one minor. And when the resistance would become very very large, so the current would be very very small. Got it? So the one more thing.
Noted.
Okay, good. So if you want to discuss about one more thing, just like we have discussed about the placing a lamp. So if we would place a lamp in the circuit, just like we are going to place a lamp in the circuit at this one place. So we have placed a lamp. Okay, so let me know that if your semiconductor diode is in the reverse biased condition and you would place a lamp in the circuit, so whether the lamp would work or not.
Semiconductor,
So your
the semiconductor and the lab are the
so your semiconductor diode is reverse biased and you have placed a lamp in the circuit. So whether the lamp would work or not.
okay. Semiconductor is reverse bias, so the lamp it will not work
It would not work. Why it would not work?
because when the diode is reverse phase, the material is connected to the negative terminal. So the the
Hmm? So you should say that the amount of current that is flowing through the circuit, that is very very small and it is not enough to make the lamp work, right? So because of it, the lamp would not be lit up when your diode is in the reverse biased, right? So jump to the next one slide. So we can say that the lamp would not work when diode is reverse biased. So if your uh, diode is placed in the reverse biased condition, then the lamp is not going to work in the circuit. Got it? Okay, very good. So the next one thing is we are going to talk about the light emitting diode, right? Okay. So jump to the next one slide. Light emitting diode. You may have heard or you may have seen the short form of this one as the LED. So you have seen that we in our homes we are using the LED bulbs. So LED stand for the light emitting diode, right? So first we will talk about the composition of the LEDs or what the LED is made from. So our first point is about the composition. Composition. So it is said that if we talk about the composition of the LED, so the light emitting diode is just like I have told you that diode is made up of the semiconductor material, but a special type of semiconductor material is used that is called as the gallium arsenide phosphide. So LED is made up of gallium arsenide phosphide. In the chemistry, you may have learnt about the periodic table. Have you studied the periodic table?
Yes, yes, sir.
Yeah. So you may have heard about the names of all these elements. You may have heard about the gallium, you may have heard about the arsenic and the phosphorus. So it means that it is a semiconductor material which is containing the three elements from the periodic table. The one is the gallium, the other one is the arsenic, and the third one is the phosphorus from the periodic table. So this is a special kind of the semiconductor material that is used to make the light emitting diode. Okay, so it is said that if we talk about the circuit symbol for the LED, so its circuit symbol is very important. So the second one point I would let you know about the circuit symbol for LED. So the circuit symbol for the LED is almost same as that of the semiconductor diode. So this type of symbol we would draw. So it's same just like this one. Here a triangle, just like we have represented the semiconductor diode. And this one, front side, here there is a band present at the front. But one more thing that is added, we would draw here the arrows. Two arrows are drawn here. Good way, these arrows are showing you the emission of light because, as the name indicates, light emitting diode. So it's a diode, but when current would pass through it, it would emit the light. So these two arrows are showing you about the emission of light. Got it?
Yes, I got it.
Okay, very good. So now we can see that if we talk about the placement of the LED in the circuit, So we can say that the second one, next point is about the working. So it is said that when you are going to place your LED in the forward biased manner in your circuit. So I would draw the circuit diagram on the next one page. So we can say that when it is forward biased in the circuit. So goodbye. Now we would draw the forward biased placement of the LED in the circuit. Move to the next one slide. Suppose we are going to place the LED as in the forward biased manner. So this is the positive terminal, negative terminal of the battery. So this is plus, this is minus. So when this type of circuit is shown, and instead of this one whole circuit, we have to put another component in the circuit, and that is basically the one more component that I'm going to draw here. So goodbye, you have to tell me that which one component that I have placed here. So goodbye, can you tell me that which one component I have placed in the circuit? What is this?
The rectangle,
Yeah,
resistor.
very good, very good. So we have placed a fixed resistor in series with the semiconductor, the light emitting diode. So this one's resistor is basically placed in order to control or limit the flow of current, because if the current would exceed a certain value, then it would damage the light emitting diode, because light emitting diodes are quite sensitive component of the circuit. So that's why we would put a resistor in the series. So when this type of circuit is drawn in which your light emitting diode is placed in the forward biased manner, so current would flow through the light emitting diode, and when the current would flow through the light emitting diode, so what would happen, the light emitting diode would emit the light. So move to the previous one slide. So when it is forward biased into the circuit, the current would flow through the LED. Move to the next one slide. So current would flow through LED, and it would emit light. And this, because of this emission of light, this diode is considered to be the light emitting diode. Got it?
Yes, sir.
Okay. So the last one point about the light emitting diode is that if you are going to place it in the reverse manner, so when reverse biased, would be, what do you expect if your light emitting diode is reverse biased? Just like I can change the polarities on the slide about this one. So suppose we are going to change the polarities. If we make the polarity just like this one, so what do you expect? Whether the light emitting diode would emit the light?
No, sir, it will not emit the light.
Why it would
It will
not
act
emit?
like it will act as an open circuit.
Yeah, so why it would not emit the light?
But it's not because the like it blocks the current flow.
Yeah, the resistance would become very large and the flow of current would be limited. So when it is reverse bias, so no current flow throughs, LED, and when no current is flowing through the LED, and there would be no emission of light. Goodbye, did you get it?
Yes, sir.
Okay, so can you summarize the whole thing that we have studied today?
Yes.
Okay,
Okay. So we'll study about semiconductor diodes, and they are made up of semiconductor material. Okay, and then the semiconductor materials. And semiconductor is basically like insulators that conduct electricity. And
yeah,
then there's and the circuit symbol is it's a semiconductor diode, which is like the left like the forward bias is the anode is positive, and then cathode is negative,
yeah,
and then the reverse bias, the anode, the reverse bias, it would be reversed. So the terminal of the charge will be reversed. So it will like be reversed So there'll be like less current flowing and more resisting.
Hmm. Good.
And then we also study about light emitting diode, which is like it's like it is made up of gallium arsenide phosphide,
Hmm.
and
Good.
it only emits light through forward bias, and when it's connected with the reverse bias, it won't emit, and it will act like as an open circuit.
Very good. So we can say that this is all about the working of the diode. Basically, the light emitting diode is one special kind of the semiconductor diode. So the basic is the semiconductor diode. So it may be forward biased, it may be maybe reverse biased in the circuit. So just like we have talked about the forward and the reversed biased of the semiconductor diode. So we have said that in the forward bias the resistance is low and the conventional large amount of the conventional current would flow through the circuit. And we have said that if we talk about the reverse bias for the semiconductor diode, so the resistance becomes very large, and because of it the conventional current would be limited. So in the same way, if we have talked about the light emitting diode, so it is the fact that when you would place the light emitting diode in the forward biased manner, so then a large amount of the conventional current would flow through the light emitting diode. And it's a speciality of the light emitting diode that when current flows through it, it would emit light, just like different colors of the light are emitted. So if we talk about the forward biased manner of the light emitting diode, so it would emit the light of the different colors, and that is shown. So if we talk about the reverse biased, so as for the light semiconductor diode, the light emitting diode would be having a lot of resistance. So there would be the very small, or you can say that no current would flow through the light emitting diode, and when there would be no current flow, so there is no light produced by the light emitting diode. Got it?
Yes, sir.
Okay. So goodbye. Do you have any question related to this one?
No, sir.
Okay, goodbye. So this was all about our today's class. So take care of yourself. Allah Hafiz.